Hello students, my name is Chaitanya and welcome to Score Physics. In this video, we are going to learn about the derivation of vector form of Coulomb's law. Vector form of Coulomb's law will be seen. Basically, we have learned that Coulomb's law of electrostatic states if there are two charges Q1 and Q2. If these two charges are separated by a distance r, these two charges will experience some electrostatic force, and that electrostatic force is directly proportional to product of the charges and inversely proportional to square of the distance between them. Okay, so now combining these two we are going to get the proportionality as q1 q2 divided by r square. If let's say we are removing this proportionality symbol, we have to add in a constant, and that constant is found to be k q1 q2 divided by r square. This is a general form of force. Now these forces depends the direction of this force depends on nature of the charge. If this is a positively charged particle and if this is also a positively charged particle, we can write force on this particular charge as F12. Okay, force on 1 due to 2, and we can write this as force F21. What we know in this system, in this condition, is F12 is actually equal to F21, but we know that they are opposite to each other when you are writing them in vectorially. So when you are writing vectorially, you have to add in a negative sign. Okay, this is what we have to prove in this vector form of Coulomb's law. Okay, and how we will be writing that we are going to see in this video. So basically, let us assume whenever we are talking in terms of vector, obviously force is a vector quantity and we have to understand its direction as well when two charges are given. Okay, so now let us assume we are having a coordinate axis. Two charges are placed at two different locations. Let's say this is charge q1 and this is charge q2, and I am assuming those two charges to be positive. Okay, those two charges are positive. Now if those two charges are positive, they repel each other. Now in order to write any forces acting on it, it is very important that we define a position vector for it. So now the position vector for q1 will be drawn from the origin. So this is my origin and this is the reference point I am taking. So I can write this one as r1 bar, which is the position vector for that particular point. And what is r1 bar? R bar is basically xi cap plus yj cap plus zk cap. It basically tells us what is the position of that particular charge in that Cartesian coordinate system. So this is the position of q1 and this is r2. The position of q2 is defined as r2 bar. So now we are always interested to learn the distance between those two charges right here. Now that is the distance between those two charges. Now here also we have to understand the same. The distance between these two charges are to be found. Now the distance between those two charges will be written as, let's say, r bar. We don't know what is that r bar. Whenever we are writing force, okay, if you have to write it in terms of vector, then you are going to write this particular force as force into direction vector, force into r cap. You can write like this. Okay, r cap is the unit vector in the direction of force. Basically we can write it like that. So now when we are writing it force, so F bar means we need force magnitude and the direction of it also with R cap. Okay. Now, how do we find this R cap? R cap is nothing but unit vector. Unit vector. Basically, if I am saying that there is a coordinate system in this direction, 2 I cap I am writing. 2 I cap means what? 2 units along x direction. Okay, which is magnitude is 2 and I cap gives you direction. If it is in any other direction, then you have to write it as 2 r cap, and r cap will give you unit vector in that particular direction of the vector. Okay, so basically the same we have written in terms of force F is equal to F bar is equal to F into r cap. Now we have to find what is this r cap. R cap is the direction of the force vector. Now here we know that these two repel each other. So when you are writing the forces on them, this is going to be F12 force on 1 due to 2, and this will be F21 force on 2 due to 1. Okay, now this is a system we are having. Let's say we are trying to understand F12. F12 is the force we have to write, and that means we have to write F12 into R12 cap. Okay, this is how we will be writing. So what is F12? How do we write force F12 magnitude? F12 can be simply written as K Q1 Q2 divided by R12 whole square, R12 whole square into R12 bar. If you are writing in a vector form, R12 bar also we have to find. But how do we find this R12 bar? R12 cap? Okay, so now we know that we are having a triangles here. This is R1 bar, this is R2 bar, and this is R bar, and we are having our force in this direction. This is F12 bar. Okay, we are having force in this direction. This is our F12 bar, and we need R bar also in this direction, and later we can find R cap in this direction. If you know a vector, we can find unit vector in that particular direction easily. How do we find it? We know a bar is a unit vector. A bar is a vector. If you want to find unit vector for it, we can write a bar divided by modulus of a bar. This is the unit vector formula, a cap. Basically unit vector means we have to get the magnitude of it to be 1. The magnitude should be equal to 1. Okay, now this is F12 in this direction. We are trying to find what is R bar in this direction first, and then we can easily find what is the R12 cap. So now here let us take the directions correctly, and if you know triangular law of vector addition, if you are using triangular law of vector addition, we know that if two sides are represented as sides of a triangle, a bar and b bar, and that too very important, we have to join b bar by the tail of this is b bar. Okay, the b bar tail should be joined by a bar head. The closing and the third resultant side, closing and the third side will give you the resultant vector in opposite direction. This is a bar plus b bar. This is your resultant vector. This is the logic, and this is how the directions are to be given. Okay, so this is how the directions are to be given. Now if you observe, okay, we want r bar in this direction for sure, because f12 is in that direction. So how do we write r12? This is going to be r12 precisely for us. So how do we write? We can write r bar. If you observe, these two are in continuation. These two are acting as the sides of a triangle. Okay, and the remaining r bar is acting as a closing side. Okay, this is acting as a resultant. That means you can write r2 bar plus r12 bar is equal to r1 bar. So from here r12 bar can be written as r1 bar minus r2 bar. This is the formula of r12. Now once you have known what is r12, we can find r12 cap. R12 cap can be written as R12 bar, R1 bar minus R2 bar divided by modulus of R1 minus R2. This is a formula for R12 cap. Okay, now using this we can easily find what is the force now. Okay, how do we write F12 bar now? F12 bar can be written as KQ1 Q2 divided by modulus of R1 minus R2 whole square, because R12 is given as R1 minus R2, right? Okay, we can write R12, the value of it as R1 minus R2 whole square. We can simply write that. Okay, R12 is R1 minus R2 into R cap. into R12 cap. In place of R12 you can substitute this. If you are substituting that in that condition, what we will be getting? F12 bar can be finally written as K Q1 Q2 divided by modulus of R1 minus R2 whole square into R cap. In place of R cap I can write R1 bar minus R2 bar divided by modulus of R1 minus R2, which will finally give me K Q1 Q2 divided by modulus of R1 minus R2 whole cube into R1 bar minus R2 bar. Okay, this is how we are going to get that formula. Now this is for F12. In the same way, if you are trying to do for F21, okay, if you are trying to do for F21, then the same condition, we know two charges are there. This is Q1 charge and somewhere here we are having Q2 charge. Now this is your R, this is your R1 bar, and this is your R2 bar. Now the force we have to find is in this direction. This can be written as F21, okay, because this is Q2 charge, force onto due to 1. Now we have to find unit vector in this direction. Okay, in this direction we can write that one as R21 cap. So to find R21 cap we can use this vector as R21 bar. So what is it now in this situation? Now R1 and R21 is acting as the sides of a triangle, and third closing side which is acting as a resultant is given by R2. Now from this situation you can write R1 bar should be equal to R21 bar, R1 bar plus R21 bar is equal to R2 bar. From this situation we can write R21 bar is equal to R2 bar minus R1 bar. Now if you are trying to find unit vector for it, R21 cap can be written as R2 bar minus R1 bar divided by modulus of R2 minus modulus minus R1, modulus of R2 minus R1. So now when you are writing F21 bar by using this, okay, if I am using this and writing F21 bar, the final value that I am going to get, F21 bar is equal to K Q1 Q2 into R2 bar minus R1 bar divided by modulus of R2 minus R1 whole cube. So basically we know, basically this is the same formula we got it here. Okay, same format of formula. We know R1 minus R2 modulus is equal to R2 minus R1. Anyhow it is the same. So we can equate those two. So if you are writing it, okay, those two formulas, if I am taking the negative sign common from this, I can write this formula as minus of K Q1 Q2 divided by R2 minus R1 or R1 minus R2 modulus whole cube into R1 bar minus R2 bar into R1 bar minus R2 bar. Now from this what you can observe, this I have written it as minus F21 bar. So that means we are proving that F12, sorry, minus F12 we have to write it here. This is actually the formula of F12, right? This one. We can write F12 bar. That means we have proved that F21 bar is equal to minus F12 bar. So I hope you understood this video. I hope you understood this concept clearly. Thank you.